DC to DC converter. So first of all we will see the definition of a DC to DC converter. So it is a converter which converts a fixed DC into variable DC. Suppose we have the fixed DC, suppose we have 50 volt is the fixed DC. We will get the DC voltage as 15 volt, 20 volt or 25 volt or more than 75 volt. That way, that variable voltage we can get from the fixed voltage. So it is called a DC to DC converter. So the main element which is involved in the DC circuit is only we have the switch. When we have the DC supply, 50 fixed DC supply, constant voltage. When the switch is on, this voltage is available. The input voltage is available at the output side. When the switch is off, that is this side. When the switch is open, there is no voltage is available on the output side. Again, when the switch is on, the voltage is available. So likewise, it is going on. So let T be the on time. Let T be the total time, which combines on time and off time. 1 by T or 1 by F. 1 by T is called frequency. That is operating frequency of the switch, which will define the output voltage V0. When we take the average of this voltage, that value is very much, if it is less than the supply voltage, that converter is called a buck converter. When the average output voltage is greater than supply voltage, that is called boost converter. So likewise, we have many converters available for DC to DC converter. The main elements involved in any DC to DC converter is supply voltage, a switch, power electronic switch, that may be a MOSFET switch or IGBT switch, capacitor, one inductor, and of course we have the load. Now we will see the buck converter operation. So as we said previously, any DC to DC converter having supply voltage, switch, this may be a power electronic switch, one inductor and one capacitor, and of course we have the load R. So we have the output voltage V0, that is nothing but the voltage drop in the capacitor. The input voltage is Vs. So the buck converter, the basic operation is the output voltage is less than input voltage. So we will see the operation of buck converter. So the operation of the converter can be explained in two modes. First on mode and off mode. During on mode, the switch S is closed. That is the switch is on. By that time, the load current flows through. So the one current is going through capacitor, that is IC. Another current is going through the load I0. So here again, these two currents are combined here. So the current flow is here. So this current is IL. So IL is equal to combination of capacitor current and load current. Now, so during this mode, there is a current flow through the inductor. The inductor is charged from the minimum value to maximum value. The inductor charges the current. It is increased from minimum to maximum. That is, it has the minimum value and maximum value. That means the inductor is charged from minimum to maximum value. So the nature of the inductor current is linear. Linear nature. Again, the next mode is when the switch is off. When this switch is off, so the next mode of operation is when the switch is off. The inductor polarity is reversed. So previously it was the inductor polarity is left side plus and right side minus. When this conducting switch becomes off, the inductor polarity is getting automatically reversed. That is a property of inductor. Now the inductor is trying to discharge through this capacitor and the load. So through this way, the inductor is getting discharged. When the polarity is reversed, this diode is getting forward biased. This minus is connected to the cathode. So this diode is forward biased. Now the inductor is discharged through this way. Previously there is no capacitor. Previously there is no diode. Now we have the diode. Through the diode, it is discharged. Now the analysis part. Come to the analysis part. So the analysis part having two areas. First during on time and off time. So during on time when you see the on time of the circuit, we have the voltage across this inductor is nothing but supply voltage and output voltage V0. So the voltage across inductor general form is L into di by dt. So this L voltage across inductor having two parts, that is Vs minus V0. This inductor voltage is Vs minus V0. Vs minus V0. Now this is a change in current with respect to change in time. So this change in time. So during on time the inductor current is increases from minimum to maximum. So this minimum to maximum we can name as a change in current that we defined as delta I. So this change in current is happen during the time t on. Now so from this equation we can write delta I is equal to this. Again t on is equal to this. These two are named as equation 1 and 2. Again come to during off time. So during off time the switch is open, there is no supply voltage. Vs, there is no supply voltage. So in this equation there is no supply voltage, only we have minus V0. So during off time the inductor is getting discharged. Now the current is decreased from maximum to minimum. Inductor is getting discharged, decreased to maximum to minimum. So this discharge we put as minus sign. Again this delta I, that is L into di by dt. This is a change in current delta I. This is happened during the time after t off. So by reducing this one, t off is equal to this and delta I is equal to this. So equation 4 is delta I and equation 1 is delta I. Combining these two, equation 1 and 4 both are delta I. So delta I and this is also delta I. So combine and this LL cancel. So multiply this T on inside. We have the answer like this. So this T on plus T off is equal to total time. So V0 into T, Vs into T on. So therefore V0 is equal to this T brought to left side, right side, T on by T. So that we called as alpha. Alpha is called duty ratio, which is defined by T on by T. So this duty ratio value is always greater than 0 but less than 1. This duty ratio value is always greater than 0, less than it may not be, it should not be 0 and it should not be 1. So for buck converter the output voltage formula is alpha into Vs. That's all.